Hi, good morning, my students. So, quadratic equation part 3 for quadratic expression and its graph. In the last session, we learned this graph of this the graph of this y is equal to ax square plus bx plus c is a parabola and vertex at minus b by 2a comma minus d by 4a when a positive upward parabola, when a negative downward parabola. Now here, for different values of ABC, for different values of ABC, the graph of y is equal to ax square plus bx plus c can be plotted in the following 6 different ways. Okay, so different values of ABC, for different values of ABC, we can plot the graph of this quadratic expression into 6 different cases. Okay, we'll get 6 different cases depending on the constants ABC values. Okay, so so clearly what is the D? Discriminant D value is what? B square minus 4AC. Okay, so the first case is, suppose A is positive and discriminant is also positive. Discriminant is also positive. So as a discriminant positive, then y is equal to 0 has, then y is equal to 0 has two distinct roots only, two distinct roots. Am I correct? Two distinct roots. So let them be alpha and beta. If alpha and beta are the roots of y is equal to 0, that means this graph will cut the x-axis at alpha comma 0 and beta comma 0. Okay. So thus we'll get the graph, and also A positive, then it is what kind of parabola? Upward parabola. So this is alpha, this is beta. Say alpha is smaller root, okay? Alpha is less than beta. So clearly, this is the graph, okay? Clearly, for what values of x, for what values of x, y is positive. So here, observe y is positive for what values of f? For what values of x? For what values of x, y is positive? See, this is only the positive part. This is only the positive part. So clearly y is positive when x value is minus infinity to alpha and beta to infinity. So that means y is a positive for what values of x? Minus infinity to alpha union beta to infinity. So for these values of x, y is positive. And clearly when y is negative, so this is the negative part only, this is the, so when x takes between alpha and beta, so y is a negative when x belongs to what? Open interval alpha comma beta. Correct? So one example, see. So for what values of x, y is equal to x square minus 4x plus 3 is positive. Y is equal to x square minus 4x plus 3 is positive. So clearly x square minus 4x plus 3, if you find the factors, what you will get? X minus 1 into x minus 3 only, no? So what are the roots? 1 and 3. Here x square coefficient is what? 1 positive. So it is upward parabola. As the roots are 1 and 3, the graph cuts the x-axis at 1 comma 0 and 3 comma 0. 1 comma 0 and 3 comma 0. So clearly for what values of x, y is positive? See, this is the positive part only, this is the positive part. So minus infinity to 1 and 3 to infinity. So x belongs to minus infinity comma 1 union 3 comma infinity. So for these values of x, y is positive. For these values of x, y is positive. Obviously for what values of y, it is negative 1, 2, 3. Okay. And for what values of y is less than or equal to 0. For what values of x, y is less than or equal to 0? Yes, it should be what? Here y is positive for these values of x. Y less than or equal to 0 for what values of x? between 1 and 3, y value negative, but at 1 and 3, y value equal to 0. So x takes both 1 and 3 also. So that means x belongs to closed interval 1 comma 3. So for these values of x, y is less than or equal to 0. So this is the first case. Next, second case. Second case, when a positive and d is equal to 0, then y is equal to 0 has what? 2 equal roots. 2 equal roots. So let them be those equal roots are alpha and alpha. Then automatically x-axis becomes tangent to this curve at alpha. Okay, tangent to the curve at alpha. That means this parabola touches the x-axis at alpha. Okay, when a positive discriminant equal to 0, then y is equal to 0 has two equal roots. Let them be alpha and alpha. Then this parabola touches the x-axis at alpha comma 0. Okay, alpha comma 0. So next to second case is third case. Remember, this third case is important. Okay. So when a is a positive, discriminant is less than 0. Discriminant less than 0 means y is equal to 0 has no real roots. No? Y is equal to 0 has no real roots. That means ax square plus bx plus c cannot be equal to 0. That means that graph of the function, the graph of that y is equal to ax square plus bx plus c never cuts x-axis, never meets x-axis. Okay. But as a positive, it should be what? Upward parabola. Upward parabola. So upward parabola never intersect x-axis. So that means the graph will be like this only. No? So if you observe, the graph of this function completely above x-axis. Completely above x-axis. As it is completely above x-axis, then clearly the value of y is always positive for all x belongs to R. The value of y is always positive because it is completely above x-axis now. Then the value of y become what? Function value become always what? Positive for all x belongs to R. So the condition for this quadratic expression ax square plus bx plus c is always positive for all x belongs to R is because y is nothing but ax square plus bx plus c only. No? So the condition for ax square plus bx plus c is always positive or it is greater than 0 for all x belongs to R is a positive, discriminant negative. That means coefficient of x square is positive and discriminant negative. So here, what is the sign of this expression? Positive sign. So x square coefficient is also must be what? Positive sign. And discriminant must be what? Negative. Okay. So this is the important case. So one example based on that. One example. So find the value of k or find the set of values of k. Find the set of values of k for which this expression is always positive or this expression is positive for all x belongs to R. Okay. So anyway here a value is how much? 1. Positive. And what is one more condition? D must be negative. D is nothing but what? B square minus 4ac must be negative. So that is 16 minus 4k negative. That means k should be greater than 4 or k greater than 4 means what? K belongs to open interval 4 comma infinity. So for these values of k, this quadratic expression is always positive for all real numbers x. Okay, so that means if you substitute k value 5, 6, etc., etc., or if you substitute 4.1 also no problem, then if you draw the graph will be completely above x-axis. That means this value is always positive. So suppose if you substitute k value 5, so x square plus 4x plus 5 you'll get. That expression is always positive for all x belongs to R. That means instead of x, if you substitute any number, x square plus 4x plus 5 gives some number which is a positive number. Okay. Next after third case, fourth case. So fourth case is similar to first case when a negative, discriminant positive. So discriminant positive means automatically y is equal to 0 has how many roots? 2 distinct roots. So y is equal to 0. That is y is equal to 0. What is y? Ax square plus bx plus c is equal to 0 has 2 distinct roots. That means the graph of this function will cuts x-axis at 2 distinct points. If we assume roots are alpha and beta, it cuts the x-axis at alpha comma 0 and beta comma 0. As a negative, it is a downward parabola. So downward parabola. So this is the alpha, this is beta. So just like second case, fifth case also. So fifth case is a negative, discriminant 0. So discriminant 0 means it has 2 coincident roots, correct? And as a negative, then parabola will be downward parabola. So as the roots are coincident roots, then the parabola will touches the x-axis. At which point? At alpha comma 0, where alpha is the root of ax square plus bx plus c is equal to 0. So alpha is root of ax square plus bx plus c is equal to 0. That means alpha is one root, other root is also alpha, because discriminant 0 only, na? So when a is a negative, discriminant equal to 0, in this case also parabola touches x-axis. At which point? At alpha comma 0. What is alpha? Root. Okay. But in case of a positive, it is upward, a negative downward. Now just like third case, sixth case also. Observe sixth case. Sixth case, when a negative, discriminant negative. That means y is equal to 0 has no real roots. Y is equal to 0 has no real roots. Y is equal to 0 has no real roots, and a is less than 0, downward parabola. From this what we can conclude? It is a downward parabola. From this what we can conclude? Y is equal to 0 has no real roots. That means the parabola never cuts the x-axis or never meets the x-axis. Okay, parabola never meets the x-axis and downward parabola. That means the parabola should be completely below x-axis. Am I correct? The parabola will be completely below x-axis. As it is completely below x-axis, the y value is always negative. The value of y is always negative because graph is what? Below x-axis. So y is less than 0 for all x belongs to R. So y is nothing but what? Ax square plus bx plus c is less than 0 for all x belongs to R. So this is also important case, third case and sixth case. That means a quadratic expression is always a negative only when its x square coefficient should be negative and the discriminant should be negative. Okay. So a should be less than 0 and discriminant also less than 0. So third and sixth case, remember carefully. You have to remember third and sixth cases. So based on these 6 cases, I'm going to solve some problems. Okay, I'm going to solve some problems. So it is given the graph of certain quadratic equation, expression only. So it is a minus 1. This is 3, 0. So this is the graph of certain quadratic expression. Okay, y is equal to f of x is equal to ax square plus bx plus c. Then which of the following is or correct? So options are given like this. First option is a minus b plus c by a b c is equal to 0. Second option, a into b into c into 9a plus 3b plus c. 9a plus 3b plus c. It is less than 0. Second option, a b c into 9a plus 3b plus c less than 0. Third option, a plus 3b plus 9c divided by abc is less than 0. Fourth option, ab into a minus 3b plus 9c, it is greater than 0. So it is a more than one option right. Okay, it is a more than one option correct type question. Okay, clearly from the graph it cuts the x-axis at minus 1 and 3. Then what are the roots? Minus 1 and 3. What are the roots? Minus 1 and 3. So sum of the roots minus 1 plus 3. It is nothing but sum of the roots formula is what? Minus b by a only, no? So, and also one more point. It is what kind of parabola? No? Downward parabola. Downward parabola means a value should be what? Negative only, no? A value should be what? Negative only, no? Okay, a is clearly negative and the roots are alpha is equal to minus 1, beta is equal to 3 and sum of the roots minus 1 plus 3 is equal to what? Minus b by a. So minus b by a is equal to what you are getting? 2, which is positive. So minus b by a positive. So that implies that b must be what? Positive. Correct? Because a is a negative. So a is a negative. So minus b is negative. If minus b is negative, negative by negative is positive. So minus b negative means b must be what? Positive. Next, product of the roots c by a is equal to what you will get? Minus 1 into 3 minus 3. It is less than 0. So c by a less than 0 means c and a are of opposite side. So a is a negative now already. So c must be what? Positive. So thus we got the signs of A, B, C also roots. Okay. So A is a negative. What we got? B value. B is a positive. C also positive. That means from this what we can conclude? A, B, C is a negative. And clearly this function is a positive between minus 1 and 3. Okay, the function is a positive when between minus 1 and 3. And clearly what is the f of minus 1? F of minus 1, if you substitute x value minus 1, what you will get? A minus b plus c. Am I correct? But minus 1 is a root, then f of minus 1 value become what? 0. A minus b plus c is 0. And what about f of 3? F of 3, what you will get if you substitute 3 here? A into 3 square, 9a. B into 3, 3b plus c. But 3 is also a root. F of 3 value, what you will get? 0. That is 9a plus 3b plus c is equal to 0. And a plus 3b plus 9c. If you take 9 common, what you are getting? A into 1 by 9 plus b into 1 by 3 plus c. It is nothing but 9 times of f of 1 by 3. Am I correct? Because it is 1 by 3 square, it is 1 by 3. Okay? Because 9c is there, make c coefficient is 1. Next, 1 by 3, where it is located between minus 1 and 3 only, no? So at minus 1 by 3, graph is above x-axis or below x-axis? Above x-axis. That means that function value is positive. So f of 1 by 3 is positive, 9 also positive, so positive into positive, positive. So thus a plus 3b plus 9c is positive. Similarly, a minus 3b plus 9c, we can write 9 into f of minus 1 by 3. So minus 1 by 3 also between minus 1 and 3 only, no? Minus 1 by 3. So at minus 1 by 3 also graph is what? Above x-axis. So f of x is positive at x is equal to minus 1 by 3. So 9 is also positive. Therefore a minus 3b plus 9c is positive. So why I am finding these two values only? Because these two are appear here. And why I am finding a, b, c signs? Because a into b into c is appear. That is why I am finding signs. Okay. Now a into b into now here observe a minus b plus c value, what we got? 0. A, b, c value is what? Negative. So 0 by negative value is 0 only, na? So first option is correct. Next, second option. A, B, C value is what? A into B into C value? Negative. 9A plus 3B plus C value, what we got? 0. 0 into negative value is 0. 0 less than 0 is wrong. So second option is wrong. Next, look at the third option. A plus 3B 9C. A plus 3b plus 9c value, what we got? Positive value. What is a into b into c value? Negative value. Positive value by negative value, what you will get? Negative. So third option also correct. Next, what is a? Negative. What is b? Positive. So a into b is negative. And a minus 3b plus 9c value, what we got? Positive. So this is a negative, this is positive, this is also positive. So product will be what? Negative. But it is given greater than 0. So fourth option is wrong. So thus which options are correct? First option and third option. Okay. Next one. So given that y is equal to ax square plus bx plus c, or you write like this, sorry, given that ax square plus bx plus c is equal to 0 has no real roots, then we have to show that c into a plus b plus c is positive. C into a plus b plus c is positive. Okay. So, you take let y is equal to f of x is equal to ax square plus bx plus c. Then according to the question, f of x is equal to 0 has no real roots. F of x is equal to 0 has no real roots. No real roots means a discriminant must be what? Negative. As discriminant is negative, depending on a value, it is either upward parabola or downward parabola. So that means the and it never cuts x-axis. That is, never meets x-axis. That means the parabola graph will be completely above x-axis or completely below x-axis because it has no real roots. Discriminant is less than 0. Suppose when a is positive, then parabola graph, the graph of y is equal to ax square plus bx plus c will be like this. Okay. So here if you observe, at any real number x, y value positive only, no? And particularly what is f of 0 value, what you will get? C, it is also positive only, no? And f of 1, what you will get? F of 1, if you substitute x value 1, what will you get? A plus b plus c, that is also positive only, no? Because as a positive, graph is completely above x-axis, so that means the value of y or function value is always positive for all real numbers x. Particularly f of 0, f of 1 also positive. That is, f of x is positive at 0 and 1. Why I am calculating f of 0 and f of 1? Because c is nothing but f of 0. This a plus b plus c is nothing but f of 1. So that is why I am calculating f of 0 and f of 1. As both are positive, in this case, what you will get? C into a plus b plus c is positive. Suppose a is a negative. Anyway discriminant is less than 0. So then the parabola is a downward parabola and it never meets the x-axis. That means the graph is completely below x-axis. That means if you take any value of x, if you calculate the function value, you will get some negative number. That means the value of this function is always negative in this case for any real number x. Particularly f of 0, the value of the function at x is equal to 0 is also negative. The value of the function at x is equal to 1 also negative. So c negative, a plus b plus c negative in this case. Then the product, what you will get, negative into negative is positive. So thus from both cases what we can conclude, c into a plus b plus c is positive. C into a plus b plus c is positive. So with this I am going to close this session. Thank you.